Welcome back. This is going to be probably um one of the last two videos for chapter 26, and I'll be posting more videos as we move along, maybe some uh, refresher videos, whatever we can do to stay busy, plus more discussion questions just to make sure that you guys are staying fresh with this, and hopefully you guys are studying. So by the time you get to this video, it'll probably be, let's see, today is the 3rd. It'll probably be well after the middle of the month, so, but that's okay. Let me move this up a little bit. All right, we're starting where we left off, spill control, uh, chapter 26, page 1340, spill control. Just note this, spill control, we're talking about being defensive. It's going to be defensive for a spill. Uh, if you mention or remember whenever we were dealing with or going through the ERG earlier, in the ERG video, we went into the isolation distance in the green section. And the ERG will list any sort of spill as a large spill as 55 gallons or more. So remember that through the ERG, it's listing large spills 55 gallons or more would be considered a large spill. So getting started, scrolling back through here. Okay. There's going to be a lot of terms in this section that you're going to have to definitely go over, and hopefully you've been going over all your everything else that we've been through. So getting started. Spill control tactics, confine. Remember, whenever we're dealing with confine, we're talking about an area versus contain, which is keeping it in the container. So confine is more of a defensive measure. To confine a hazardous material that has been released from its container. Know these tactics. Tactics attempt to, know this, reduce the amount of contact product makes with people, property, and the environment. One of the important things, even though you may be wearing protective chemical gear, whatever the case may be, stay out of the product if possible. Limit the amount of potential harm that the product causes. Control actions involving spills are generally defensive in nature. Used to confine hazardous material after it's released. It's often simply called confinement. Primarily acts as a defensive operation, and responder safety is a primary consideration. Spills may involve gases, liquids, solids. Product involved may be released into the air as a vapor or gas, into the water, or onto the surface. Type of release determines the spill control method needed to control it. Methods to prevent the spread of liquid materials include building dams or dikes near the source, and we're going to get into each one of those terms, catching material into another container, directing or diverting the flow to a remote location for collection. Now, we need to know that before using equipment to confine spilled materials, the incident commander needs to seek advice from technical sources. Determine if the spill materials will adversely affect the equipment. So those are some things that the IC needs to know and you need to know. If the spill involves corrosive material, it will react with metals or damage other materials. Large or rapidly spreading spills may require the use of heavy construction type equipment, floating confinement booms, and special sewer or storm drain plugs. Uh, there are times where we're trying to control maybe a spill, and as far as the department, we just don't have enough materials uh, available, so we have to call for help. And a lot of times, what we can do is we can either call whether the city or Department of Transportation, and sometimes those guys have maybe sand, that they can bring by dump trucks and those sort of things, and they can actually bring a lot more material. And that's just something that you would have to call for. And remember, if you need it, something we mentioned earlier in the other earlier chapters was if you need it, call for it and call for it soon. Spill control is not restricted to controlling liquids. Responders may also need to control dust, vapors, or gases with protective covering consisting of a fine spray of water, layer of earth, plastic sheets, salvage covers, foam blankets on liquids. Strategically placed water streams can direct gases or allow water to absorb or move through them. Reference sources and training information can provide proper procedures for confining gases. Confinement efforts dictated by material type, tools and equipment needed, rate of release, and the weather. Also, speed of spread, topography, and the number of personnel available. So let's get to our terms. And we're going to start on page 1343, absorption. We're going to start off, we'll add this, so make sure you get this down. One substance combines with a second substance. One substance combines with a second substance. So, soaks up or retains a liquid hazardous material and some other material. So, the examples is like a sponge soaking up water. Bulk of liquid being absorbed enters the cell structure of an absorbing medium. When choosing absorbent, it must be chemically compatible with the material being absorbed. Absorbents tend to swell as they absorb the material. Now here's some common absorbents that can be used. Sawdust, clays, charcoal, polyphen type fibers are specially designed absorbent pads, pillows, brooms, or socks. Absorbent is spread directly onto the hazardous material. Know that, spread directly onto the hazardous material or in location where the material is expected to flow. So right there, we can actually either pour it on top of it, and what we use is basically, and the most common, is just what we call, kitty litter. And so we can pour it right on top of it, or we can actually pour it around it and try to confine it that way. After use, responders must treat and dispose of the absorbents as hazardous materials. Now for us, what we do is we have to call for somebody to dispose of that. The fire department does not dispose of hazardous materials. So we have to call the city environmental. They'll either come pick it up, or if it's a very, very large spill, then we have to call a company that deals with picking up hazardous material and disposing of it properly. And if we go back to the laws that we went over on basically the last day of class, those laws is what dictates that stuff has to be disposed of properly. You can't just dump it in a trash can. All right, so we do need to know that they must treat and dispose of the absorbents. Also, responders often use absorbent in incidents involving small spills, and the text here is even giving 55 gallons or less, so large spill 55 gallons or more, such as gasoline or diesel fuel. Some absorbents, such as sawdust, may work best for shallow pools. Other types of spills may require different type of absorbents. Now, add this when we talk about absorbent, not effective. It's not effective as far as spills in water. So if you've got a lot of water and you've got maybe a hydrocarbon or something on top of that, you would have to have copious amounts of absorbent to try to soak all that up. So just know that it may not be as effective whenever we're dealing with spills in water. All right, which leads us to the next one, adsorbent. Don't get these two mixed up. They're two different types of controls here. So the difference, adsorbents. It's the molecules of the liquid hazardous material physically, and here's the key word, physically adheres to the absorbent material rather than being absorbed in the inner spaces. Adsorbents tend not to swell like absorbents do. Responders usually use an organic based material such as activated charcoal or carbon as an adsorbent. Adsorbents primarily control, know this, shallow liquid spills. Increasingly replace soap and water with other decon methods. Make sure that adsorbent is used compatible with the spilled material in order to avoid a potentially dangerous reaction. So again, make sure that whatever you're going to add to, if you're going to use an adsorbent, that the material that you're putting it on is not going to have a reaction to that. And also you can add to adsorbent, it also reduces off-gassing. So you can add that to your notes. Reduces off-gassing. Blanketing and covering. Blanketing and covering. Performed to prevent dispersion of a hazardous material. Operations level responder may not be allowed to perform blanketing covering actions depending on the hazardous of the material or the hazards of the material, nature of incident, and distance for which they must operate to ensure their safety. Responders must consider compatibility between material being covered and material covering it. Tools for blanketing and covering solids. You can use your tarps, plastic sheathing, salvage covers, those sort of things. It may be done in a form of a temporary mitigation, maybe for a radioactive or biological substance. It says it can reduce alpha-beta radiation. Personnel can blanket or cover incidents involving cryogenic leaks caused by released materials. It can also, as a temporary option, responders can cover openings of some small liquid containers. Now, blanketing liquids is essential, the same as vapor suppression, because it typically uses copious amounts of appropriate aqueous or water foam agent to cover the surface of the spill. So just know that you can use blanketing just like vapor suppression. And we'll move on to the next, dam, dike, diversion, and retention. And I'll kind of go, hopefully this kind of goes over, it kind of breaks it up a little bit, but as I'm looking here, 1345, it's giving you some pretty good examples. If you look up on figure 2639, it's giving you the example of a dam. And if you notice, when we were in class last, I went over the examples of underflow and an overflow. And that's basically what you kind of see in that picture right there. So a dam and the water. Now you see a dike. They took a dike, maybe some absorbent, something like that. That is on land. And the other two, divert, retain. I also give you some examples at the bottom of diking and actually damming and diverting. So, all right, actions performed to confine or control a hazardous material, control the flow of liquid hazardous materials away from a point of discharge. So we need to know that. Responders can use available earthen materials or materials carried on their response vehicles to construct curbs that direct or divert the flow away from gutters, drains, storm sewers, flood control channels, those sort of things. In some cases, it may be desirable to direct the flow into certain locations in order to capture and retain a material for later pickup and disposal. Some dams may permit water surface or runoff to pass over or under while holding back the hazardous material. Responders must properly dispose of any construction materials that has been in contact with the spilled material. I'm going to add something to that also, is understand that materials specific gravity when building a dam. Know the material specific gravity when building a dam. Is it going to float on top of the water? Is it going to mix and sink? So you definitely need to know that. That's going to determine whether you're going to build an overflow or an underflow for a dam. Vapor suppression. Vapor suppression. We'll start off, add this, vapor suppression, controlling fumes. Controlling fumes. All right, so reduces the emission of vapors. Responders use vapor suppression when they are applying firefighting foam to suppress vapors from flammable and combustible liquids. You need to know that. Other examples of vapor suppression include using water fog from hose strings or chemical vapor suppressants. Vapor dispersion. You need to know that this directs or influences the course of the airborne hazardous material. So here you are going to use pressurized streams of water from hose lines or unattended master streams that may help disperse the vapors. These streams create a turbulence. They increase the rate of the materials mixing with the air, and they reduce the concentration. Know that, reducing the concentration of the hazardous material. You also need to know that after using water streams for vapor dispersion, you must confine the runoff if possible. Make sure you confine the runoff. Ventilation. Ventilation is performed to control air movement using natural or mechanical means. When spills occur inside a structure, ventilation can remove or disperse harmful airborne particles, vapors, and gases. Personnel may apply the same ventilation techniques that they use for smoke removal to hazmat incidents. I'm going right on to, well, let me back up. Needed to go over these two. Responders should ensure compatibility of ventilation equipment with the hazardous atmosphere. Here's one. This is, you need to know. Make sure that it is intrinsically safe if you're in a flammable atmosphere. And also, when choosing the type of ventilation to use, remember that positive pressure ventilation removes atmospheric contaminants more effectively than negative pressure. So remember that. Positive pressure is going to be a little bit better than negative pressure. Dispersion. Dispersion. Need to know that this is breaking up or dispersing a hazardous material that has spilled on a solid or liquid surface. Both chemical and biological agents disperse hazardous materials. Personnel usually using dispersion agents on hydrocarbon spills. Dispersion poses problems, often has unfortunate effect of spreading material over a wide area. Dispersion process itself may cause additional problems because these problems, the use of dispersants, may require approval of government authorities. So make sure we know those, the problems that dispersion may pose. Make sure you go over that. Dilution, application of water and a water-soluble material to reduce the hazard. Make sure you know that. Dilution of liquid materials rarely has practical applications of hazardous incidents in terms of spill control. Responders use dilution more frequently during decontamination operations. Know that. Diluting hazardous water solubles requires huge volumes of water that may create runoff problems. So remember, if we have any runoff problems, we need to do our best to actually try to confine that runoff. Responders may use dilution at spills involving small amounts of corrosive materials, generally considered for use only after spill control methods have been rejected. So remember the runoff contamination, and also add this: dilution may be effective when combined with other containment tactics. Dilution may be effective when combined with other containment tactics. Know that. Neutralization. Some hazardous material may be neutralized to minimize the amount of harm that they do upon contact. Something you need to know here usually involves raising or lowering the pH of a corrosive material to render them to neutral, and neutral is 7. Know that. Term can be applied to any chemical reaction that reduces hazard of the material. It's a difficult process. Adding too much neutralizer can cause the pH to shift in the opposite direction. So if you have an acid, you're going to use a base to try to neutralize it. If you use too much base, now you have basically an alkaline that's going to be higher on that end. So basically, you're going to have to research how much are you going to have to use for that particular product. With few exceptions, responders should only conduct neutralization under the direction of a hazard material technician or allied professional or your SOPs. Flammable and combustible liquid spill control. Most hazmat incidents involve flammable and combustible liquids. Incidents range from spilled fuel at auto accidents to most industrial accidents involving bulk containers. Spill control methods used will depend on the incident. Know that. It will depend on the incident. Now here's some things we must know. Always consider firefighting protective clothing can absorb flammable and combustible liquids. Know that. And that can ignite if exposed to an ignition source. Know that. Avoid contact with products and or contaminant pools, puddles, or streams. Vapors from flammable and combustible liquids are usually going to be heavier than air. Flammable and combustible liquids are typically lighter than water, and if so, will float on the surface of the water. So we already said the vapor density is greater than 1, and the specific gravity is less than 1. Flammable combustible liquids are Class B materials. Water is an ineffective extinguishing agent. Flammable combustible vapors may be toxic. For example, just know benzene is a carcinogen, a chronic problem that you might have, cancer causing. We need to know that controlling vapors is priority at a flammable combustible liquid spill. Controlling vapors or liquids, controlling the vapors. So make sure you know that. Vapor suppression using firefighting foam can be effective if foam concentrate is compatible with the hazardous material. Responders must proportion and aerate all foam concentrates before using them. Mechanical foam concentrates are divided into 2 categories based on the classifications. And when you did your liquid fuel fires, and also you may have gone over the Class A, Class B foams. So Class A foams are for ordinary combustibles, and Class B foams would be flammable combustible liquids. And you can add this real quick. What's the difference between a flammable combustible liquid? Flammable liquid is going to be anything with a flash point above 100 degrees Fahrenheit. Flash point above 100 degrees Fahrenheit. A combustible liquid would be the flash point is below 100 degrees Fahrenheit. So make sure you know that. Class B foams may have significant differences. So know that responders should not use regular fluoroprotein and regular aqueous forming foam on those particular type materials. Responders may use concentrates that are intended for polar solvents on hydrocarbon fires. So whenever we're dealing with flammable combustible liquids, you have to research what type of material you're going to be dealing with, because if you're going to use foam, you definitely have to use the proper foam. Foam concentrates, they vary in their finished foam quality and effectiveness. Manufacturers and suppliers will be able to provide information about freeze-protected versions of foam. Foam quality is measured in terms of its 25% drainage time. I'm going to move through this. Let's go to all Class B foam concentrates except special foams made for acid or alkaline spills may be used for both firefighting and vapor suppression. Air aspirating nozzles produce larger expansion ratios than water fog nozzles. All foam have different optimal application methods. Know your methods for foam is either you're going to use a roll-on application, and that's applying the foam on the ground near the edge and rolling it on. You can also use what's called the rain down method. The rain down method is where you're basically using your nozzle and you're spraying the nozzle in the air and you're allowing the foam to rain down on top of the product. And then we have what's called a banking off. So you're using, if you can't reach that material, maybe there's something in the way, you can actually bank it off of a wall or a tank or something like that. But what it's getting at, so we've got roll on, we've got rain down, and we can bank it off of another fixed location, whether a wall or a tank or something like that. But what it's getting at is never apply the string directly into a flammable combustible liquid because you will disperse it, you'll spread it. Now, once your blanket of foam is applied, it needs don't add anything else to it. That's what we want it to do. The foam can roll over the top of the material, and then it's going to suppress those vapors. And if it is fire, we can pretty much extinguish that fire. But what we want to do is keep that layer of foam on top of there to keep those vapors down so we don't have another flare up. So do not use water streams in conjunction with application of foams. Water destroys and washes away the foam blankets. Ensure that the material is below its boiling point. Foam cannot seal vapors of boiling liquids. Do not rely on the film that precedes the foam blanket. It is not a reliable vapor suppression. Reapply aerated foam periodically until the foam completely covers the spill. So do not use water, that's very important, in conjunction, and reapply until the foam is completely covering the spill. Got some examples here on 1352, so look at 1352. It's the roll-on method. It is the bank down method, and they're using a fixed tank to actually bank off of it. And then you see the rain down method. So that gives you some pretty good examples. Okay, responders should consider many factors at hazardous material incidents where flammable and combustible liquids are present or burning, and that's including where vapors may be present or traveling, and where and what possible ignition sources are present. If the products of combustion present fewer hazards, then the leaking chemical or extinguishing efforts will place firefighters in undue risk. The course of action may be to protect exposures or let the fire burn until the fuel is consumed. Responders should consider withdrawal as potentially safest tactical option due to if you have the threat of a catastrophic container failure or a levy, resources needed to control the incident are unavailable. So that might just be withdrawal from a safe distance. If flammable liquids have produced enough vapor to ignite, the incident will change focus to fire control. Fire control attempts to minimize the harm and the damage and the effect of the fire at a hazardous incident. Fire control tactics aim to extinguish fires, prevent ignition, and flammable materials. Fire control tactics may be offensive or defensive depending on the situation. Okay, we're going to add something to that. Whenever we're talking about some of the threats, responders should consider withdrawal as potential as their best tactical option, potentially the safest. Want to add something that it's a term that you might come across this, so just add it in case you see it. There is a term called flaring, F-L-A-R-I-N-G. Flaring is controlled burning of a liquid or gas to reduce the pressure. So there are times where we go to calls where they are flaring, and it is controlled, but It looks like a house fire or something of that nature. You will get calls on it. Sometimes it's very bright. But being here in Corpus, you can definitely see they have a lot of flaring going on at certain times. But just know that flaring is a controlled burn of a liquid or gas to reduce the pressure. Just wanted to add that. Okay. Well, we may have a couple more pages, but I'm going to stop this one right here.